Hi, welcome to DataClassroom. I'm Aaron Reedy, one of the co-creators of DataClassroom, and I made DataClassroom to solve a very real problem I was having in my classroom and one that you might be having as well, and I hope that we can help. So the problem was when we would do a really great lab and we'd collect data, I usually succeeded in sucking the fun out of the lab completely by having students struggle through making graphs in Excel and doing analysis. And we never really got to have the kind of great conversations about data. What do these data mean? What conclusions can we draw from them? Those are the conversations you want to be having. And I hope that DataClassroom makes it easier to have those conversations. So let me show you around DataClassroom, and I hope that you'll reach out and talk to us so we can have an even more in-depth conversation about what we have and what we've made that can help you. So this is the DataClassroom website. If you haven't visited yet, you should, and you can register a password for free and begin playing with data. I want to draw your attention to our Ready to Teach lab. So you can see up here on the purple nav bar, if I go to Ready to Teach, these are all data sets that are pre-made and preloaded on the DataClassroom app, and these are complete lesson plan ideas that are fleshed out, and you can use these for free with your students tomorrow if you wanted to. I want to show you one in particular to show off some of the graphing and statistical capabilities of the app. I want to show you this potato osmosis lab. So I'm going to click here, and just to give you the anatomy of a Ready to Teach lab, all of these Ready to Teach activities have the background of the lab. This is sort of the least your students would need to know to make sense of the data. And they have activity questions, as well as examples of the graphs that your students will produce with the web app as they answer these questions. So I'm going to jump into the web app and start playing with some of these data here. So this is the absolute classic lab called potato osmosis. This is where you take small chunks of potatoes and you place them into 6 different solutions of sucrose. Sometimes I've seen this done with salt. And the response variable that you're measuring is how much does this potato change mass. And so this is the spreadsheet here that you're seeing, but I'm gonna jump to the make a graph. So you see this tab at the top. I'm gonna go ahead and jump to make a graph because this is where the fun stuff happens. So to plot a variable, you see these column headers here at the top, and each of them have this big green show button underneath it. And I'm gonna click this one for mass change, and boom, that's it. So one click, and I've made my first graph in DataClassroom. You can see each dot in this, on this plot is a different row in the data set, and quite literally, each one of these was a different piece of potato that students measured. And so you can see this dot plot is showing you this distribution of mass change. If I want to see this in a different format over here, I can click a different graph icon. So I'm going to click the histogram/frequency plot. And now you can see this plotted as a histogram. So right away, you're teaching kids to move through different modes and different representations of data. But I'm going to go back to this scatter, box, bar, or categorical bubble. This is a really flexible graph type. And now I'm going to add a second variable to the plot. I'm going to add this sucrose concentration molarity. This is a numeric variable as well. So you can see I have a numeric y, numeric x. And now as I do that, I start to get new options that appear over here on the right. And so like regression line, I'm going to add that. And so what you see here is our philosophy is we only show students options as they become relevant. So once regression line became something that might be relevant, we added it as an option, and your students can click that. Then you can see the default is a linear regression, but they could do, say, a quadratic regression if they wanted to fit a curve to there. I also want to point out that you can customize every aspect of this plot visually, right? So if I open this appearance menu here, I can say, oh, I want to do things like change the size of the points. You can see these big fat points, or I can crank these down and make them smaller points. I could do things like, change the color of the data points. I could also choose to represent them instead of with dots, but with this data emoji. And you can see this chooses from a huge library. There's 3,600 symbols that students can choose from. And maybe I want to represent these as potatoes because each data point quite literally was a piece of potato. So you can move through these different options. And in this quick demonstration, I'm just going to keep adding complexity to this. So this is a numeric X and a numeric Y. Let me show you what happens if I take this sucrose concentration variable and I make it into a categorical variable. It leaves the plot, and I'm gonna add it back. And you might be wondering, oh, wait, how can you make that into a category? Those are numbers, but those are also 6 different experimental treatments. So there was this 0% sucrose, there's this 0.2 molarity sucrose, there's this 0.4. These are actually each treatment. So you could represent this data as a categorical, and you'll notice now you get this option to control the jitter. And I can spread the points out horizontally. That jitter just means horizontal spread, but they're grouped by these different categories. And now I get this other option for descriptive stats. So one question you might be asking students to find is, what is the average for each of these groups? What was the average mass change? And I could add descriptive stats right here. And so now you see it showing the mean mass change for each group is pictured with the dot, and the error bars are showing the 95% confidence interval. I could do things like, oh, maybe I'll show that as a standard error of the mean, or maybe I'll show that as a standard deviation. And you can see that the error bars change as I do that, and the fine print below the graph changes to reflect that. I could also do a median-based representation, and now I'm showing a box and whiskers plot. Or I could, choose to show mean and median at the same time. And this is a powerful teaching tool to show kids that all 3 representations, the raw data points, the mean or the median, these are all showing the same data, but plotted in different ways. So maybe I'll just go back to we'll add the median and the raw points there. So sort of the first layer of complexity, and this is something you might do with middle schoolers, is just show the raw points. And then as you move up in sophistication, you might choose to add one of these things like a box plot or the mean and the error bars. And then if you're really moving into more advanced data skills and more advanced ways of thinking about these data, you might choose to do inferential statistics. And this button over here is the graph-driven hypothesis test. And if I click this, it will recommend that you do the ANOVA test, or the analysis of variance test. And this is how you test for statistical significance. So if I click this, it will give me this test, and it will run the results, and it will show me, oh, here is my p-value of less than 0.01. And if I click this explainer, it will point out to your students that the question they're asking is there a significant difference in mass change percentage between sample groups with different values of sucrose concentration molarity? And it'll show you that answer on a number line that you can explore the parameter space here by dragging this. But when I let it go, it will snap back to the calculated value and give the students the hint that 0.01 for a p-value means that these groups are most likely different. And the text on this window helps explain that this is not a yes/no question. And science is really poorly equipped to give you a yes/no answer. But what science can do is measure the strength of the evidence. So I just want to leave you with the sense that DataClassroom is ready to meet your students wherever they are in terms of skills with data analysis. It's going to make basic graphing easier. And then as your students grow or get older, they're able to move through layers of complexity, so they can go from just graphing raw points to adding statistical visuals that represent descriptive statistics, all the way up to inferential statistics. There's much more that I'd like to show you about DataClassroom and what it can do. It can also do animated hypothesis tests. So please reach out. I'd love it if you would join us in the chat and talk to us live in the next few minutes. But if you can't, you can email us at info@dataclassroom.com, and we'd love to schedule a video call with you to show you all that DataClassroom can do. I hope to meet you soon. So thanks for joining us.